Hello viewers, in this video we explain the slope of CES production function. Q is equal to A into alpha k to the power minus rho plus beta into L to the power minus rho whole to the power minus 1 by rho, where Q is output, K is capital, L is labor, A, alpha, beta and rho are positive constants. Now, the total differential of the function q is equal to q of k comma l with respect to k and l is dq equal to del q by del k dot k, not k, that is dk, plus del q by del l into or dot dl. So this is called the total differential of this function, where dq is equal to partial derivative of q with respect to k into dk plus partial derivative of q with respect to l into dl. Since an isoquant represents a particular amount of output, or an isoquant represents a particular amount of output, the output on an isoquant does not change, or dq is equal to 0. Therefore, del q by del k into dk plus del q by del l into dl is equal to 0, because this portion is equal to this portion and this dq is equal to 0. Thus we get del q by del k into dk is equal to minus del q by del l into dl, or dk by dl is equal to minus del q by del l del q by del k. And that is equal to minus del q by del l, that is partial derivative of q with respect to l, is equal to marginal physical productivity of labor. Since q is output, l is labor, and when we differentiate q, that is output with respect to l, and that is called the marginal physical productivity of labor. And similarly, del q by del k is equal to mppk, that is marginal physical productivity of capital. So we get marginal physical productivity of labor divided by marginal physical productivity of capital. So dk by dl, that is the slope of the isoquant, is equal to negative of the ratio of mppl and mppk, or the slope of an isoquant is the negative of the ratio of marginal productivity of labor and capital. In CES production function, MPPK, that is marginal physical productivity of capital, is equal to del Q by del K, and that is equal to del by del K, that is partial derivative of this function, that is A into alpha k to the power minus rho plus beta L to the power minus rho whole to the power minus 1 by rho. Now, in order to take the partial derivative of this with respect to k, let us take alpha k to the power minus rho plus beta L to the power minus rho as another variable, say u, and we get del u by del k equal to del by alpha k to the power minus rho plus beta L to the power minus rho del k, and that is equal to minus rho alpha k to the power minus rho minus 1, or that is equal to minus rho alpha k to the power minus rho plus 1, or minus rho into alpha divided by k to the power rho plus 1, and del u by del L equal to minus rho into beta divided by L to the power rho plus 1. Now, MPPK is equal to dq by dk equal to partial derivative of this with respect to k, and that is equal to del in partial del or partial derivative of a into u to the power minus rho del k, because u is equal to this. Using the product rule of differentiation, we may write it as del a into u to the power minus 1 by rho with respect to u into du by, so del u by del k, and that is equal to the derivative of this portion with respect to u is equal to a is the constant, so 1 by rho, this is the power of this u, so u to the power minus 1 by rho minus 1 into del u by del k, that is derivative of u with respect to k, is equal to minus rho into alpha divided by k to the power rho plus 1. So we put this value here, that is minus rho into alpha k to the power rho plus 1. Here this rho and this rho will be cancelled, and minus into minus will be positive, so we get a into u to the power minus 1 by rho divided by u because of this minus 1 into alpha divided by k to the power rho plus 1, and that is equal to alpha into a into u to the power minus rho divided by u into k to the power rho plus 1. Again, u is equal to alpha into k to the power minus rho plus beta into L to the power minus rho. Here we put the value of u, and finally we get MPPK, that is marginal physical productivity of capital, is equal to alpha into A into alpha into k to the power minus rho plus beta into L to the power minus rho whole to the power minus 1 by rho divided by alpha into k to the power minus rho plus beta into L to the power minus rho multiplied by k power alpha plus rho plus 1, and that is equal to alpha, that is nothing but dq, divided by alpha k to the power minus rho plus beta L to the power minus rho into k to the power rho plus 1. So marginal physical productivity of capital is equal to this. Similarly, MPPL is equal to, so instead of alpha we get beta, so beta into q divided by alpha k to the power minus rho plus beta L to the power minus rho into, instead of k here we will get L, rho plus 1. Thus we get the value of MPPK and value of MPPL. Now the value of dk by dl is equal to minus MPPL divided by MPPK. Here we put the value of MPPL and MPPK, and we got this. The value of MPPL is this, already we have got it, and derivative value, value of MPPK is this. Here we have put their values, and after solution we'll get, after simplification of this we get this, and this q will be cancelled. Again this portion and this portion will cancel. So this is not beta, this is alpha. So that is equal to minus beta k to the power rho plus 1 divided by alpha L to the power rho plus 1, and that is equal to minus beta by alpha k by L whole to the power rho plus 1. Since beta, alpha, rho are the positive constant and capital and labor are also positive, so because of this negative sign, this is nothing but negative or less than 0. Here we get dk by dl less than 0 or negative, so the isoquant of CES production function is negatively slope, or the slope of the isoquant of CES production function is dk by dl equal to negative beta by alpha into k by L whole to the power rho plus 1, that is less than 0. Again d square k by dl square, that is second order derivative of k with respect to L, that is derivative of dk by dl with respect to L, and that is equal to this, and the value of dk by dl is this minus k, because derivative of L with respect to L is 1. Now here we have here minus sign, here also we have minus sign, and here also we have minus sign. So by taking this minus sign, we will get positive here, and that minus sign will be cancelled by this minus sign. So finally we get d square k by dl square equal to this. Here all are the positive sign, so that is greater than 0. Here we got d square k by dl square greater than 0, that is we get the second order derivative of k with respect to L is positive. So the isoquant of CES production function is convex to the origin, and the graph of the isoquant of CES production function will be like this. So this horizon, if the horizontal line is labor and the vertical line is capital, the isoquant will be like this. So this is a downward sloping convex curve. So the isoquant of CES production function is negatively sloped and convex to the origin, and that is indicated by dk by dl is less than 0 and d square k by dl square is greater than 0. So this indicates the negatively sloped curve, and this indicates the convex curve. Thank you.